Hey, Professor Ashwin here, just going over the answers to the final exam. We'll speed through this. Used to hold values of different data types. That's going to be a struct. This is what we use, the game state struct. Can be used to hold the state of the 3x3 tic-tac-toe board. That's going to be a 2D array. For those of you who came into lab and we did the low shoe magic square, it kind of looks like that. Typically used to iterate through every element in an array. For loop, we gave credit if you said while loop as well, but typically we use a for loop if we're going through every element in an array. Like an array, but the number of elements can change. That's the main benefit of a vector. That's why we briefly learned about that. Used as a return type if function doesn't return any data. That's void. All right, array processing. Sum only the odd numbers in the array. I thought students would do a little bit better on this one. Like, we've done a lot of problems in homework 9, lab 9 with summing elements in the array. Homework 9, we did taking the average of the numbers, where you had to go through every element in the array and add them together. Homework 10, we did where you had to add every element in a 2D array. So if not the if statement, I was hoping at least this line and the for loop students would get. And this one here, like if we're trying to get the sum of something, we need to set int sum equal to 0. For loop is the same that we've done for every array problem for the most part. So int index equals 0, index less than the size of the array, in this case it's 5, index plus plus. This was maybe the part that was going to be a little bit tricky and I thought maybe students wouldn't get. So I gave the hint, number mod 2 equals 1. How can we get the number in the array? Nums of index. So that will give us one of these numbers like 5 or 2 or 1 or 3 or 14. We use the mod symbol with 2, and if that equals 1, a lot of students who got the problem almost right just did a single equal sign. Again, if we're checking for equality, you put 2 equal signs. So if that's equal to 1, then in here, we want to increase the sum. So with increase, we use the plus equals operator, and we want to increase that element because we know at this point, this nums of index has to be odd, so we add it on. This is the same thing as saying sum equals sum plus nums index, so either works. Debug my code. So first mistake, line 5. We're returning true or false, so return type needs to be bool, not char. Next mistake, line 6. Again, iterating through strings is similar to iterating through arrays. We start the index at 0, not 1. Line 7, this was the double equality mistake that students were making in the previous problem as well. Letter equals with 2 equal signs, word of index. What's next? Line 17. Bool result is equal to in letter, char letter string word. So when we call a function, we don't put the data types. We're just passing in the data. So we just can give in letter and we can just give in word. So bool result is going to be equal to that. And then finally on line 20, letter is not in the word. We don't need word in quotes. Move quotes around word. We just wanted to print out what word is, which is exam. Okay, two-dimensional array. Students mostly got this one. So we add the table. There's going to be 2 rows and 3 columns. So sometimes the students got it wrong. It's because they were doing 3 rows and 2 columns. We still gave partial credit there. The first row, 2, 11, 7. Next row, 5, 13, 23. And then we say nums of 0, 2. So this is row 0, column 2, which is this value here. That changes to a 4. So that would be your final answer there. Conditional expressions, x greater than 8, that is false. Or y doesn't equal ball, that is also false. So false or false equals false. This one here, x greater than 3 and less than 7. This one's going to be error. A lot of students caught this. You would need it to be and x less than 7. You need both conditions to work on their own. Big O notation, hit or miss. Students generally got this one, runtime of lines essentially 8 through 10. That's going to be O of n, because if words is n elements long, like if there were 1,000 words, line 9 would run 1,000 times. Runtime of lines 12 to 14, students generally got this one as well. No matter how big words is, These three lines are always just going to run in the same amount of time, O of 1. Runtime of this big while block here. This is exactly the binary search code. So in class, we did it with numbers. Here, I did it with words. It still works. But the runtime for this is going to be O of log n, because every time we shrink the problem in half. So we either increase like the start to be the middle plus 1, so that shrinks it in half, or we do end equals middle by 1. So we're always shrinking the problem in half. So it's going to be O of log n. And then I told you on your note cards to put down the ordering of these runtimes. O of 1 is the fastest, O of log n is the next fastest, O of n is, in this case, the slowest. So the overall runtime of this function is just going to be the slowest one, which is O of n. Function output. Students did really well in this one, so I was happy to see. In this case, function a does all this work, but we don't assign any of those values. So we call function 8, but we don't modify cat or dog in the main function. So in this case, cat stays at 5, dog stays at 8. So cat equals 5, dog is 8. And that's because these values never get modified in the main function. Okay, question 2. Here, so cat is never being modified. What the heck? Okay. Cat never gets modified in the main function, so cat stays at 7. And then dog is equal to the result of function b, 8 and 5. So that's like saying x is equal to 8, y is equal to 5. So here cat is equal to 8 minus 5. We return that, so we return the value 3. So dog is going to be equal to 3. And again, even though cat is also equal to 3 here, this is in a different function. We only care about what's here in the main. So cat and dog get modified on lines 14 and 15, and that's how we get the values 7 and 3. For the coding part, where'd it go? Okay. For the coding part, is game over function. So returns true if the game is over, or false otherwise. So we know this is going to be a bool. This problem is identical to the ones we did in homework 8 and homework 11, where I asked you to create an is game over function. So is game over, it takes a couple parameters. The first one is it num case is left. You can see all of these are numbers here. So the first one has to be a number. And then the next one is going to be a bool for is deal accepted. We have an if statement because we're either returning true or we're returning false. And I gave you your conditions. So if there's one case left, we can represent that as num cases left equals 1. Or essentially, if one of these are true, then we're good. Is deal accepted equals true. Then we can return true in this case. Else we can return false, but because it's a function, you don't have to include the else. You can just say return false. That one works there. Okay. Students generally did pretty well on the is game over. The open case, I think, was not as good for students. So create a function open case. The function does not return anything. I was happy to see students mostly got this part right with the void. Open case, and it takes the parameter of cases, so double cases array. In here, ask contestant, select a case from 0 to 4. So cout, select a case from 0 to 4. We need to store this somewhere. So let's create a variable that's like case index. This is like the case that the user is selecting. So we can see in the case index. People generally got this far, and then I think this part was really confusing to people. I think arrays in general, maybe, when I look at the completion percentage for the array, labs, and homeworks, it is lower than the other assignments. And I think it really showed on this exam. Like if you didn't do 2D arrays, if you didn't do 1D arrays, this exam was going to be hard. And I don't know what to tell you, because I said the best way to prepare for the exam is to do the assignments. The fact that we still got less than 60% completion, there's a very strong correlation between people who did the assignments and people who didn't, and how well you did on the exam. So essentially we're couting the case, essentially the case index that they just chose. Then we're telling them it contained a certain amount of money. And so it's like if they chose case 1, that would be like saying cases of 1. If they chose like case 4, then we'd want to say cases of 4. Essentially, whatever they chose, that's the case index. That's what we put in here. And then an NDAL at the end. And in a similar vein, we now want to set that case index. This is just normal array modification. We take whatever index and we set it equal to 0. So let me just mark that to make sure it's correct. Okay, cool. Calculate offer. I thought this was a friendly problem towards students because it's essentially just taking the average. We had this exact problem on homework 9 where I said the average of the cooking scores, the cooking competition problem, just putting it in a different context, but the fundamental coding is the same. So in this case, we're going to return a double because we could be returning a decimal. Calculate offer, and all it takes is an array of cases and the number of cases left. We need to know number of cases left so we know what to divide by. In here, we need a sum because we're essentially summing all the elements together first. So for int index equals 0, index less than 5, I said you can always use 5, index plus plus, sum plus equals cases of index. So we're essentially doing this part here where we just add together all the elements in the array. So now we have our sum, and then if we want the offer, that's essentially like the average. So we just take the sum divided by the number of cases left. Like the sum was this thing here, and then we divided it by 2 in this case because there were 2 cases left. Or here, the sum was these 5 elements added together, and then we divided by 4 because there's 4 elements left. And then you can return the offer. Like that, should be good. Okay, and then copying all these functions over to the final code. I was hoping to see students get more partial credit on this last one, especially given that I gave you the pseudocode. And if you essentially typed in any of these things, like even the comments, I would have given you like partial credit. I think students got in their heads because maybe they weren't doing as well on the earlier parts of the exam, and they just didn't even attempt this part. And that was a little bit sad to see. Going forward, like exams will be challenging in your other classes. As much as possible, try to get partial credit wherever you can. Like, so for this part here, just adding your code. Even if you've done nothing right up to this point, like I give you what to write here. Like I tell you, write while is game over. And then try passing in parameters. Like you know that there's 2 parameters, and it's num cases left and is deal accepted, which I give you these values here. Num cases left, is deal accepted, and I say set that equal to false. Literally, if you just did this, I would have given you 5 out of 15 points. So kind of disheartening for me to see students not trying to get points wherever they could. Hopefully use this as a learning lesson in your future exams. Even if you're not doing well on an exam, still get through every problem and try to get points wherever you can. Okay, so we say open case. Open case is a void function, so we don't need to assign it anything. And open case just takes an array of cases, which we have here. So we pass in cases. Remember, when we call a function, we don't need to say like what the data type is and like it's an array. You just pass in the values. Okay. Then we decrease num cases left by 1. So you can do minus equals, or you can write it all out. Then we call calculate offer, and we assign it to the offer variable. So we have this offer variable I've given to you. So we have to say offer is equal to calculate offer, and we see what parameters calculate offer takes. It takes 2 cases and num cases left. And then final part, get the deal, and we can assign it to is deal accepted. And that's going to be this code that I gave you, get deal decision, and it just requires the offer as a parameter. So if we mark that, get deal decision, sorry, I made a typo. Okay, cool. Thanks, everyone.